Okay, folks, we're going to get started here. Our next presenter is Norman Brandiger. He's coming to us from the well-known Vonage. He's going to be talking about using the Midregistrar module along with registration redirection. Say that fast 15 times. You will actually get 2 tickets for the raffle. Oh, that's right, the raffle. So everyone should know that at the end of tomorrow, we're going to be holding a raffle. We've got some pretty cool prizes. The main prize is a authentic looking Harley Davidson jacket that's commemorated specifically for this event. So we'll let you take a look at those tomorrow, but just kind of keep that in the mental Rolodex. You're going to chastise me up here. Really. Without further ado, Norman, please take her away.
Oh, do I get a mic? Or do I have to just scream?
Norman.
No.
Norman, every other person that's come up here has put a mic on. Why did you think you were special? Got it?
Wait, can you hear me? In the back? In the front?
Put it on your lanyard, Pepper. And just remember when you're talking, don't do this to everybody who represents the street.
Oh, this is great. You can't hear me? That's even better. Speak. Testing. Hi.
Yep, there you go. No, put that on your
Okay.
Take 2. Without further ado, Norman.
Hey, thank you. Had some great presentations this morning. Lots of different subjects. A lot of different ways companies are solving various problems. I'm going to focus this talk primarily on the OpenSIPS Midregistrar module. It's not going to go too much into how Vonage uses it. Vonage is a large voice over IP provider in the States. One of the first voice over IP providers that came about. We're doing lots of interesting things. The Twilio discussion earlier was great because 2 years ago, Vonage purchased Nexmo, which is trying to catch Twilio. I think they're the number 2 provider. They're out of London, and so we're really opening up our network and our back end via APIs, the way that Twilio is doing things. So their talk was actually really, really good, really interesting.
You can ask him for the PDF for next year's presentation?
Of course we're going to ask him for the PDF for the next year's presentation. The onset presentation was also great, talking about the way that they have long-term registrations to solve some of their business problems. The Midregistrar, however, is used to solve a problem that you don't solve by having long-term, hour-long, multi-hour-long registrations, but where you have devices with shorter registrations. The problem that we've seen at very high loads is that there's a lot of registration traffic that hits the registrars. So there's various solutions where you scale up with multiple registrars to handle this traffic. The folks at OpenSIPS in 2.3, Livu was the developer behind the Midregistrar module, did a great job at solving this problem with both the team. To solve the problem where you've got a tremendous amount of traffic that's hitting your registrars, and you need to find a way to not just continually build up registrars and throw hardware at the problem, but try to come up with a more elegant solution. And that's what the Midregistrar module was designed to do. It came out in OpenSIPS 2.3. 2.4 was announced today. Obviously, if you've been on GitHub, you could pull down 2.4 for a while. It's got lots of updates to the Midregistrar module because it's a little bit newer, but it's really solves a great problem. It is a component that sits between your end user, your client, and the main registrar. The idea is that it's going to take high traffic coming from your end users, whether they're mobile devices or desktop phones, and take that high traffic, those high registrations, and cause your, it's basically a proxy in front of your main registrar, so that the main registrar takes a lot less load, which means you can have many more customers per registrar, and that's the main use for it. So we're going to talk a little bit about standard registration flow. This is a very simplified diagram. I'm sure at least I hope we kind of know what the simple registrar flows are. You send a registration in. Usually it's rejected with a 401. You then have to send another registration in with authentication information. At that point, the registration is stored by the main registrar. 200 OK comes back. OpenSIPS generally stores, or then you store the information in the user location table on the main registrar. That's the standard flow. In order to implement, actually, with the standard flow, the expiration time is provided by the client. The registrar, however, can override that, and this is where we have the ability to actually put the mid-registrar. When the registrar overrides the expiration time, the client must accept it. So if you have a client coming in with a 3,600 second registration time, and the registrar, in our case, may lower it to say 45 seconds, you're going to send that 45-second registration time back to the client, and it's going to have to accept that. So in 45 seconds, or maybe even what we found with many clients is that it's even half the time, the client will send a re-registration. So you can say every 30 seconds, that client will come back and re-register, providing a tremendous, hitting your registration server with a tremendous load. So that's the problem we're trying to solve, and the mid-registrar solves that problem very nicely. The mid-registrar sits, as I said, between the client and your main registrar. As I've explained, and these flows are simplified. There's no authentication, as I said, shown here just to simplify the diagram. The registrations will hit the mid-registrar. The mid-registrar then sends a very high expiration time to your main registrar. The 200 OK comes back. The mid-registrar saves that information and sends the 200 back to the client with the shorter registration. There'll be a couple of other slides that show this a little bit more, but the idea is that your main registrar can have a very, very high registration interval. The mid-registrar can have a much shorter registration interval, expiration time, actually, and it takes a tremendous load off of your main registrar. Fundamentally, that's the goal of the mid-registrar. The mid-registrar has a couple of different modes that it operates in. It can throttle. One of the modes is throttling by contact. So what you can see is that, Alice, your typical Alice and Bob example, but you've got Alice registering. She hits the mid-registrar, and the very first registration moves off to the main registrar, but the mid-registrar saves that information, and subsequent registrations, the second set of green lines on the left, shows that subsequent registrations from Alice's devices only hit the mid-registrar. They don't go all the way up. So the mid-registrar is really, taking care of that load. And the flow is showing clearly how the main registrar is getting much less action. So while this diagram just shows one subsequent registration, excuse me, Alice's device can register, many, many times, and all of that load stays off your main registrar. If she has a second device, she's now got her desk phone, the same process happens. And this is more or less a simple, one of the modes, I won't say simple, but one of the modes the mid-registrar works in. Again, the main goal here is to keep the load off of the main registrar. Now, incoming calls are nicely handled in a manner. You get the invite into your main registrar, and it does a lookup, and it says, "Oh, yep, I've got Alice's device," and it routes the invite to the mid registrar and then back down to Alice. That's nice, and that works pretty well. The problem is that you don't save any. You don't really have any savings on incoming calls. You also don't have the main registrar using less contacts. So remember, each registered contact generally has an entry in the user load table. If you've got lots of contacts, it starts becoming an issue. In this mode, where you're throttling registrations by contact, you don't really have any savings on the main registrar in terms of contact volume. You do based on registration volume, but just not on contact volume. So that's where another mode of the mid-registrar was created, and that's where the mid-registrar can throttle by AOR. Now, AORs are kind of interesting. I did put all of my notes in this deck so that when you have an opportunity to download the PDF or the PowerPoint from the OpenSIPS site, you'll be able to get some of the notes, because I tried to consolidate all the information, or as much information as I could about the mid-registrar in one place. Not everyone is super familiar with address, your AOR, your address of record. So in my notes that I put here, I also included just a couple of sentences from the RFC as to what the address of record is. But basically, it's the public address of Alice. It's not necessarily a device address. It's not her mobile device address, and it's not her desk phone device address. It's generally like the public address that Alice is reachable from, and so, or reachable to. And so that's actually a very key point in making the throttling by AOR work and be successful. Because if Alice has got two devices that are illustrated, you'll notice that the first registration has the AOR set to Alice. It's basically a pseudo kind of an AOR, a pseudo username at the mid-registrar. That's very key because Alice's devices, both her desk phone and her mobile phone, can be reached by an invite coming to the main registrar, and the main registrar saying, "Oh, look, I've got to send something to Alice, so I'm going to send it just to Alice at the main registrar, at the mid-registrar," and then the mid-registrar can handle the incoming forking, whether it's serial forking or parallel forking or whatever, but it can handle the forking. So the value, the benefit of throttling by AOR is that while yes, you've saved your registrations on the incoming side from the client device registering to the mid-registrar and then hitting the main registrar, the invites coming into the system from the other side can just hit the main registrar, and then just a single invite goes down to the mid-registrar, and the mid-registrar then has the function, which is closer to the edge, to handle whatever sort of forking the business logic desires, whether the forking is parallel forking or serial forking. Another tremendous benefit of of having the mid-registrar in front of your main registrar. And the mid-registrar can oftentimes sit on your edge device, your SBC at the edge. Your customers are going to be connecting to this edge, as many large systems, as we saw again earlier this morning, are set up as. By putting the mid-registrar at the edge, you'll notice that the authentication information, your password database, doesn't need to be there. Your passwords and all your security information can reside on your main registrar. Now, if you put your main registrar on a private network, a 10 network, for example, it's going to be a little more difficult for that secure information to be exposed to your clients, or to the customers, not clients, your customers. Those aren't the people you need to worry about, but it's going to be less likely that this information is exposed. So the mid-registrar, along with the performance enhancements, does actually provide a level of security by pushing that authentication data, which is actually very secure, passwords, even though it's hashed, your password's up inside your cloud, inside your network. So that's actually a very valuable piece. I kind of explained this slide previously, parallel forking with the AOR mode of throttling, where you have your invite from the main registrar and it goes out to your mid-registrar at the edge, and that's where your parallel forking is done, not inside your network. Again, the idea is to push keep this traffic at the edge and try to reduce load on your internal network. Again, I'm not going into how you would build your internal network. I'm just trying to explain the mid-registrar and kind of where it sits and what its capabilities are and what some of the valuable functions that it provides. So the AOR forking mode, or the AOR throttling mode, is really the most efficient way of handling the situation. Now, there may be ways in your particular business that this works. Maybe a partial solution works. But again, this is a tool in the toolbox. It's a relatively new tool out in OpenSIPS 2.3 with tremendous enhancements I won't say tremendous, but a number of enhancements in 2.4 that was just announced today. Again, to summarize, there are three different modes. The first mode is just mirroring your registrations. You would put this mid-registrar between your client and the main registrar. It basically can act as a registrar proxy, if that's what you want. And most of the time, or not to say most of the time, but in some instances, you would put this mid-registrar on your edge. You could certainly have an edge and then a mid-registrar in front of it, and then a main registrar. But again, it depends on that decision is a business decision based on how you're implementing it. But one way, a simple way, is to put this on your edge. The registered contact, because obviously what you're going to do with this mid-registrar is also have user location data stored locally, as well as on your main registrar. So that's only stored on 2XX responses. And as I explained earlier, an example of the value of this is to keep your password information, or keep any other secure information that the main registrar might have access to. Keep that inside your network, and don't bleed that over to anything on the edge that the public is talking to. The second mode, which starts providing some levels of efficiency, is the contact throttling mode, where the mid-registrar can give your end user device a very short re-registration interval, expiration time, and the main registrar has a much longer re-registration time. That way, you are really reducing registration load on your main registrar. Unfortunately, this doesn't help with the number of contacts on the main registrar, and it doesn't help with invites that come in from the main registrar if there's some forking that needs to happen. So if the main registrar, if there's a forking need because Alice has a desk phone and a mobile phone, this solution would require the main registrar to perform the forking. As I said, whether it's parallel forking or zero forking, that load is still on the main registrar. The third mode of the main registrar, the last one, is the AOR throttling, which provides the most efficient way of processing both inbound and outbound traffic. Traffic meaning the registrations coming in, they get throttled. Yes. They get throttled the way the contact expiration times were throttled, but there's also the benefit of the main registrar being able to just send Alice's information, invites to Alice, to the mid-registrar for the forking to happen at the mid-registrar side of things. So you've got efficiencies on the inbound side and on the outbound side. Again, the mid-registrar module is brand new to 2.3 and enhanced in 2.4. Is a great module. We're certainly looking at implementing it at Vonage because of our load and the number of customers and some of the values, as I said, from a security standpoint that it provides. Again, as I said, the reference deck, the PDF or the PowerPoint is going to have all this information, so you can certainly refer back to it. Livu is here. I think he's in the back. If you've got questions, more detailed questions about the mid-registrar, he's here to, he's able to answer them. There's a lot of information online in the standard location, along with a tutorial, a couple of blog postings, and a YouTube presentation showing how the mid-registrar has helped registration rates in Asterisk. I would like to thank you, and certainly a shout out to Bogdan and his team for helping keep OpenSIPS going all these years. Look at the size of this crowd. I mean, it keeps growing. Livu for developing the mid-registrar module that solves a tremendous need. I was speaking with him earlier today. I can see that after the mid-registrar module, maybe a mid-subscribe module might be in the works, because the other, I'm sure this is what we do, guys. You've got registrations that are a lot of traffic, and probably the number 2 amount of traffic that's, I won't say useless, but the number 2 type of traffic are subscribes and notifies. So if we could find a mid-registrar solution for subscribes, that would be fantastic. And the OpenSIPS community, which is basically just Alex. Thank you. And everyone here, thank you very much.
Thank you.
Thanks, Norm. Anybody have any questions for Norm?
I second the
You eager?
Listen, I second the mid.
You're a regular around here.
We have a second for the mid-subscriber module.